Geometry Concept 44 Teacher Talk. In this teacher talk, before attempting this one, we need to make sure that you've gone ahead and tried this problem on your own. But before that, you make sure to go to the future channels and watch the correct Robot Rover video. You can find this on the Canvas page by clicking on the correct link there on the home page. If you've already done this, please go ahead and proceed. In this problem, we're going to be talking about the Mars Robot Rover, which has 4 wheels. Each of these wheels is turned by a motor. In order to accomplish its mission, the robot will be required to move around on the surface of Mars, starting and stopping for about 60 days. Testing of the kinds of motors that will be used on the wheels show that the probability that a motor will fail in 60 days of start, stop, start running is 3 out of 1,000, or 0.003. However, if only one motor fails, the robot can keep moving. Both motors on a side must fail to stop the robot. So remember, probability here is always going to be the likelihood of the event happening. So in this case, we're talking about the probability of the robot failing its mission, or in this case, stopping completely, is about 0.003, or 3 out of 1,000 chances. And we also have talked about before that if we remember the rule of probability for independent events, so independent are those that are not going to be reliable on each other, that the probability of both events, so the events A and B happening, is the probability of A times the probability of B. So if we are trying to find the probability of two things happening, we're going to multiply their individual probabilities times each other. And so in the first one here, it says, what is the probability of failure of both of the two motors on the right side? Well, if we think about this, we have that keyword both. And so the probability of a motor failing is that 0.003. And if there are two motors on the right side, in this case we have those two wheels, one for each, then the probability of both of the motors failing would be the probability of the first failing, which is that 0.003, times the probability of the second failing, which is also 0.003. We can also write this, though, as 0.003 squared, which is about 0.00009, or 9 out of a million chances of that happening. So we're just going to multiply those times each other, because one motor times the second. Number 2 here says, what is the probability of failure of both of the two motors on the left side? Well, again, the probability of a motor stopping, or a wheel in this case, is that 0.003. Since there's two on the left side the same as the right, this is going to be the exact same calculation. So we have 0.003 for the first motor, 0.003 for the second one, and we're going to multiply those together to get that 0.00009. Okay. Now, on number 3 here, it says, let's find the probability of the right or the left sides failing, or how to fail the mission here. So we fail the mission if the right or the left side fail. So if we want to use the or, now this is going to be, another way of saying or is either. Now we're going to use our rule of probability here that says the probability of event X or Y, that's the same thing as saying the probability of the first, or X, probability of the second, Y, but then subtracting off the product of the two. Because remember, if the product, that multiplication, was the same thing of X and Y. So it's like we're taking the probability of the first plus the probability of the second, but then subtracting off the likelihood of both of them happening, because we just don't want to double count it. So if we set that up here, that we know here that this is the same thing as the probability of the right plus the probability of the left minus the probability of the right and the left failing. And so we talked about before, the probability of the right is that 0.003 times 0.003, since there's two motors, plus the probability of the left failing, which was the exact same from part 2. But then we need to subtract off the probability of the right and the left failing. So that would be that 0.003 squared times 0.003 squared. And so we have the right, probability of the right failing plus the probability of the left failing, and then subtracting off the likelihood that both of them will fail, because we don't want to double count it. So if we type that into our calculator, we get out about 0.000018. So that means there's a very, very, very small chance that that either the right or the left will fail. Now, let's go to number 4. Suppose we put 3 wheels on the side of the robot. So no longer are there just 2, there's 3. So that all 3 motors must fail to stop the robot. So as long as one of them's working, the robot's still going to go. We want to know what is the new probability of the mission failure. Well, remember, mission failure is if one side of the robot can't work. So that means either the left or the right have to fail, which means that at least one of those wheels on either the right or the left is going to have to fail. But since there's now 3, that's going to change our probability here. So instead of just let's just go back to the probability of the right. Remember, if we had the probability of the right failing was that 0.003 times 0.003. But since we now have a new wheel, we're going to have to multiply it again by 0.003 because it's the first motor times the second motor times the probability of the third motor now. And we can write that as 0.003 cubed, which is about that 0.0000027. So even a very small chance. So just adding that one more motor just makes the likelihood of failure even lower. But since that's the probability for the right side, that's going to be the exact same probability as the left. And so we can, since this is the probability of mission failure, which is the right or the left, we can use that exact same probability formula that we used in number 3. So we're going to use the probability of the right, that 0.003 cubed this time, plus the probability of the left failure, which is 0.003 cubed as well. But then we need to subtract off the probability of the right and the left failing now, which is going to be that 0.003 cubed times 0.003 cubed. And if we go ahead and plug that onto our calculator, we get that 0.000000054, which, if we think about that, that's even a smaller likelihood of failure, which makes sense because if we're adding one more extra motor, then that's going to ensure that the right or the left side is going to actually work, then there should be a smaller chance of failure. So just adding that one extra wheel in motor is really going to help our Mars rover be successful. The key takeaways here are that if we are trying to find the probability of 2 events happening, so the probability of A and B, that and means we're going to multiply those probabilities together. But in the case if we're trying to find the probability of A or B, then that means we're going to add. So you either add those probabilities together and subtract off their intersection, or just adding them together if they are independent. If you have any questions here, please go sure to ask your instructor or rewind this video if you have questions.